So now we're actually going to move on to the Couette flow scenario. I went ahead and changed the length and the height for the pipe in order to maintain our laminar flow that we are looking to achieve. I made the length 250 millimeters instead of 500 and the height 5 millimeters instead of 10. Aside from that, the meshing remained the same. Now we're going to go ahead and move on to our setup for the Couette flow, which maintains some of the same conditions, just switching up a little bit of the numbers. So in the models, we're going to make this model laminar. Hit OK. I'm going to change our residuals. We'll make sure that they're correct value, and they are. We're going to go down to our inlet. We're going to change this to a pressure inlet instead of a velocity inlet. We're going to prevent reverse flow and apply that to our outlet. Make sure it's a pressure outlet, and we are going to prevent reverse flow as well. And for our walls, we're going to make sure our lower wall is stationary, no slip. That's okay. And then our upper wall, we're actually going to set it to moving wall for this Couette flow. And the speed for that wall, I'm going to go ahead and make it 0.24 meters per second in the positive x direction. I'm going to go ahead and apply that and close it. And I am going to make sure that our air here is the values that we want it, and it is. I actually made it a little more viscous in comparison to the Poisson flow. I'm going to make sure that's updated, and then we're going to go down to our initialization and initialize it. And once this is running, I'm going to make sure that our calculation will run in 200 iterations, and go ahead and calculate it, and I'll be back. So now that our calculation is complete, we can go ahead and hit OK and close out of this, and we can open up our results to go ahead and get our velocity profiles and our contour. So same as last time, we're going to create lines here. We can create the midline, and this is going to be at 0.125. And same with this one, and the height is now going to be 0.005 with 100 samples. And we're going to insert another line, our end line, at 0.499924, 0.24999, and our height here, same as last time, and make it 100 samples, and you can see it appear on that side. And lastly, our developing flow, and there you can make this 0.01, make this 0.01 as well, and make the height same height, 100 samples. You can see it appears in there. And we can now set up our first contour and make the location the symmetry plane for the velocity that we are looking for. Make this 110 contours to make sure that it's nice and fine, and then hit apply. And we can see here that that approaches the velocity that we made it go to, which adds up. And now we're going to go to our chart viewer and create a chart. You can title this Velocity Profile for Couette Flow Data Series. We're going to create our data points here, and make sure we get all of the right ones for developing flow. And that's that. Our x-axis will be our velocity and our y-axis will be the height. And if we go ahead and apply this, we'll see here, yeah, pretty linear flow. Now if we want that developing flow, because it looks like it's almost fully developed very early on. So if we come back here to our developing flow and change this by half and go ahead and apply it, we can see there that the closer we get to the start of the pipe, the less developed that it becomes. And so this is the velocity profile and our contour here.